The topic which I am going to deal is soil health management. The soil health management is very important. We have learned that soil properties influence the soil health. These soil properties are in turn are affected by the different agriculture practices which farmers follow. Good agriculture practices not only help in managing the soil but also improve the soil health. So, what are these good agriculture practices? Let us know. The good agriculture practices that help in improving and managing the soil health mainly focus on different aspects like improving and maintaining organic matter in the soil, avoiding tillage practices which harm the soil structure, conserving the soil from erosion and other soil degrading effects, adapting integrated nutrient and pest management practices, and rectifying the soil problems like acidity, alkalinity, and saline alkalinity. So then the conserving the soil from degradation. There are the different degradation process of the soil, how to conserve. So the soil degradation mainly it refers to the changes in the soil from its original nature. So the changing from the original status to some other different status, that is bad state, that is called soil degradation. So soil degradation results due to the many different agricultural activities followed by the farmers. The visible soil degradation is due to the mainly soil erosion. So that is the loss of soil through the water. So the invisible soil degradation happens due to the loss of plant nutrients and many useful microorganisms, that is called chemical degradation, and damage due to water logging and soil compactness, which these are called as a physical degradation. So that is some are the visible degradation, some are the invisible degradation. Visible is the soil erosion, invisible is the loss of plant nutrients and damage to the microorganisms and soil compactness like physical problems. So you see the graphic way, that is here you can see here the water erosion. There is blue color represents the water erosion. So 56% of the soil degradation is due to the water erosion. That is the loss of soil through the water. Next coming followed by the 28% of the degradation due to the wind erosion. So loss of topsoil particles through the wind. So next followed by the 12% degradation due to the chemical, and finally that is degradation. So this is the representation of the different soil degradation processes. So soil erosion results due to the washing of the rich topsoil from the field due to the gravity of the water from heavy rainfall or wind. So if soil is slopy, if heavy rainfall due to the water, the water will flow along the slope and it carries the topsoil, and hence the loss of topsoil due to the water gravity. That is called soil erosion. So different conservation practices in situ which we follow to avoid to restrict the soil degradation. That is one is the ridges and furrow system in the cotton. So if we sow the cotton crop, cotton seeds, if we sow and the crop will come along the ridges and furrows, we can get the additional yield of the 500 kg of the cotton per hectare over the farmer's practice. Then reduce tillage. The tillage is the harmful for the soil degradation. So tilling only the areas that matter while minimally disturbing the soil. For example, tilling between the furrows. Suppose if we make the total plat into ridges and furrows, we'll take the sowing in the furrows only. So that is the tilling in the furrows, leaving other area of the soil. So that is minimum tillage. So then the loss of soil through the erosion will be restricted. That is the reduced tillage. Next is the stubble mulching, leaving the crop stubble on the field as long as possible to keep the soil covered. This will lead to reducing the evaporation, and it will suppress the weed growth and allow the soil microorganisms to decompose the plant residues very effectively. Another aspect is the zero tillage. There is no tillage. Simply immediately after of the harvest of the crops, we will take up the sowing without any tillage. That is zero tillage. And there are the different rice management, residue management practices which affect on the soil physical indicators in the top layer soil in sandy loam soils under rice wheat cropping system. This is the average of the 5 cropping cycles of the rice wheat cropping system. If we see the one treatment is the residue removed, and another treatment residue simply burnt, and third treatment residue is incorporated. If we compare these three treatments, the highest organic carbon in the soil was recorded due to the incorporation of the residue in the soil, followed by the residue burnt and residue completely removed. So similarly, the mean weight diameter of the soil is also highest due to the residue incorporated in the soil, and that is a good character of the soil, that is the reducing the bulk density when the residue is incorporated into the soil. So then different areas, for some areas they will have gentle slopes, some areas they will have, I mean, middle level slopes, some area they will have, deep slopes. So further depend upon these different slopes, different practices we are advising to the farmers. This is one is the contour bunding. It consisting of the building earthen embankments across the slope of the land, following the contour as closely as possible. So across the slope, we'll construct this earthen embankments. Then they will avoid the loss of the soil due to the erosion. So a series of such bunds formed on the fields, dividing the area into different, number of strips, which act as the barriers to the flow of the water, thus reducing the amount and velocity of the runoff water, and it leads to the better filtration, and it restricts the loss of the soil. Then coming to the areas with gentle slopes, here we'll advise the contour cultivation. So this is the contour cultivation. Contour cultivation is the practice of conducting field operations such as plowing, planting, and cultivating the land across the slope rather than up and downhill. So across the slope, we'll take up the plowing and planting the crops. So the ridges or broadbed furrows and the crop cover on the contour rows hold water and thus prevent the runoff water and in turn soil erosion. This is you can see this in picture, the cultivation of the crop across the slope, which helps in retaining the 10% of the more rainwater in the soil. Then third category, the areas with the steeper slopes. So here we will advise to the farmers the terracing. So the ultimate in soil conservation on steeper hills, it is the terracing. It is extensively practiced in plantation crops and paddy cultivation on the hills, where water is also harvested at the same time. Terracing can reduce erosion in many fold. So this is mainly has been taken in the hilly areas. So then this experiment I already told you. So then biochar application. The biochar is nothing but it is the this is the black carbon produced from the biomass, different biomass sources like wood chips, plant residues, manures, and other agricultural waste products. So this is nothing but the carbon sequestration. So biochar application, it controls the burning of the residues to get the product biochar uh, that has high amount of nutrients, and this high amount of nutrients, and also it will have high nutrient holding capacity. So 1 to 2 tons per hectare it is recommended. So then different practices which we follow are the cover crops or green crops. The green crops are nothing but legume crops, just like legumes, grasses, and others directly adds the residues. So legume, we know very well that legume crops that are pulses mainly those will add nitrogen from the atmosphere by fixing the and by fixing the atmospheric nitrogen into the soil. So non-legumes they scavenge the nitrogen, and these green crops, green manure may be added before or during or after the main crop. So we can add at different levels also. It reduces the losses from the erosion and it suppresses the weed growth. These are the different in situ conservation practices are recommended. One is the mulch cum manure technique. Here, the sunflower, the sun hemp green manure is recommended for the black soils. In this plat, the sun hemp was taken, and in this plat, glycidia and green manure in the sorghum and castor crops it was taken. So due to this, the 40% reduction in the runoff was observed, and it reduced the evaporation and increased the infiltration, and also it supplemented the nutrients like nitrogen, phosphorus, and it has added the organic carbon content to the soil. This is the incorporation of the green manure crop in paddy field. The how the after application of the green manure, this how it is being plowed with the cattle pair in situ in the paddy field. So this is the Pongamia growing along the bund in the field. So you can harvest these leaves and crops and incorporate into the soil. This is glycidia used as a green manure crop. This is the intercropping of the castor and pigeon pea. Here the pigeon pea is a legume crop. It fixes the nitrogen from the atmosphere into the soil. So then organic amendments. So there are different practices of the under organic amendments. The manuring is the one. The what happens while our manures is different organic manures like farmyard manure, compost, vermicompost, poultry manure like that. So this manuring it will add directly organic matter and also nutrients to the soil. It decays over the period of years. Manures will different. Generally, it varies based on the sources like animal feed, animal type, and handling system, and also depends upon the storage of the manure. This is the poultry manure application. We have different number of poultry farms in and around the farmers' fields. Nowadays, in all the different areas along in the even in Telangana and even in the country also, lot of poultry farms are being managed by the farmers and others. So the poultry manure we can get very easily at the source of the manure, organic manure. So here is the incorporation of the poultry manure in the soil. This is the vermicompost. We will produce the vermicompost. We will prepare the vermicompost using the, worms. So the vermicompost is a fine and clean organic fertilizer. It is rich in the nutrients when compared to the farmyard manure. So then adding the materials from of the farm. So we'll get the compost, municipal leaves and food processing residuals from outside, and we'll add to this, soil, add to the soil in the cultivated area. So it directly increases the organic matter, also it adds the nutrients. You know very well, organic matter is the one addition, and also add little quantity of the nutrients. So many decreases the losses, it improves the yield and reduces the erosion. So this is the shank tilt silt applied to the soil to increase the soil texture, and this is the compost heap. The farmers themselves are preparing the compost using the cow dung and waste material in the, their cattle sheds. They develop the compost themselves. So this is the heap. So they use this compost. They will apply into their fields. This is the organic manure spread on the soil. So different management practices that modify the soil organic matter are one is the tillage. So the more tillage is, the more loss of the organic matter. So the tillage, it leads to the loss of organic matter. And when we will add the organic residues, it add the organic matter to the soil. That is the place it shows. And rotation with different crops. For example, if you include in the rotation the legume crop, it will add nitrogen, and it will add in turn the soil organic matter to the soil. Then perennial crops like fruit crops, if we take up these fruit perennial crops, it will add a lot of organic matter to the soil. And bare fallows, if fallow soils are also, it leads to the loss of organic matter. So the crops with extensive root system, they lead to the more amount of organic matter added to the soil. Then conservation, it leads to the addition of the organic matter. So the soil improvements with organic amendment additions, the long-term effects which we can see here, the increased biological activity and often increased diversity. So with the addition of the organic amendments, organic manures, the lot of microbial activity is generated, increased, so it leads to the maximum biological activity and microorganisms will be very much active. So there is decomposition will take place and it will lead to the unavailable form of the nutrients to make it to the available forms. So it increases the total organic matter and active fraction of the organic matter and it increases in persistent aggregation. It improves the soil tilth and also it improves the water holding capacity and it increases the infiltration, aeration and ease of tillage and other improvements associated with the soil organic matter levels are cation exchange capacity, buffering capacity and nutrient availability. So other additional benefits due to the application of the organic matter, it reduces the soil erosion by improving the soil structure and increasing the water infiltration and absorbing the impact of the wind, rain and irrigation water. It protects the soil from extreme temperature fluctuations. It also buffers the changes in the soil pH. It stores the carbon, protecting the atmosphere from the carbon dioxide. There is a much carbon stored in soil than in all plants, animals, and the atmosphere combined. Then problem soils for better health management, soil health management, not only taking care of the degradation, we should also take care of the problem soils. Different problem soils are there like saline soils, alkaline soils, and saline alkaline soils. So soil saline, this is regarding to saline soils. Soil salinity occurs due to the high concentration of the salts like chlorides of calcium, magnesium, and sodium at the root zone. So this is the mainly due to the increased levels of the salts concentration at root zone. That is mainly chlorides of the calcium and magnesium and sodium. So the electrical conductivity is the more than 4 millimoles per decibel. So the water availability to the plants in under saline conditions is affected in such soils and consequently the plant growth is retarded and restricted. So how to, how to amend, how to take care, how to rectify the soil salinity, it is corrected by the leaching of the salts out of the root zone. So the roots, wherever the zone is there, beyond the root zone, we have to eliminate the salts. So for that, the total field should be divided into smaller plats, and bunds are formed around the plots to impound the water. So we have to make the total plat into smaller plats. Each plat can be, formed by the, strong bunds around the small plats, so that the water will let into the small plats. It will make into impound. Drains are constructed around the field for proper drainage of the water from the field. So after what happened, after impounding the water for some days, so salts will be dissolved in the water. So if we have to form the deep drains around the plat to remove the salt water from the soil. The plots are the small plots, what I told, these are flooded with the good quality of the irrigation water up to 15 to 20 centimeters. The water is impounded for 2 to 3 days to dissolve the salts, and then the water is drained out of the field. The flooding and drainage are to be repeated 5 to 6 times till all the soluble salts are leached from the soil into safer zones, and are to remove the salts which are dissolved in the water, removing the water through the drains. Then second problem is the soil alkalinity. Soil alkalinity is nothing but due to the high amount of the exchangeable sodium percentage. If the soils are having more than 15% exchangeable sodium percentage, the soils are called alkalinity. This will have comparatively higher pH. So this can be overcome by the converting the exchangeable sodium into water soluble salts and then leaching the soluble salts out of the field. So then, what we have done for the soil salinity, we will break the small plants and import the water, and the what happens, the then leaching of the salts to the safer zones. So that is one. Another one is the application of the gypsum. So the gypsum is nothing but the calcium sulfate, it is a byproduct from the fertilizer factories. It is used to rectify the soil alkalinity. So gypsum contains calcium sulfate. What happens by adding gypsum? Though this sulfate ion will replace with the sodium, the calcium ion will replace with the sodium, and the sodium will be dissolved in the water, and sodium dissolved water shall be let out from the field. The required quantity of the gypsum, it depends upon the amount of the exchangeable sodium. If soil is having more amount of exchangeable sodium, the more the amount of the gypsum is required. So the soil test will reveal the amount of exchangeable sodium in the soil. Then third problem soil is the soil acidity. Soil acidity is nothing but soils having the very low pH and low electrical conductivity. The salts are very less, but the pH is also very low. It is less than seven. These are called the acidic soils. Even if soils are having this pH even less than 4 or 5, those type of soils are called acid sulfate soils. So the crop growth is very poor in the acid soils, mainly due to the poor root system, and it adversely affect the microorganism activities. So the low availability of the nutrients like nitrogen, phosphorus, calcium, and magnesium and molybdenum. Generally, the acid soils due to the low pH, you know very well the optimum pH for the availability of the most of the nutrients is the neutral soils, that is 6.5 to 7.5. If the soil is below that pH value or it above the pH value, some of the nutrients will become deficient and availability will be less. So in the acidic conditions, the nutrients like nitrogen, phosphorus, calcium, magnesium, and molybdenum, they will be deficient. The low availability of these nutrients will persist. So the soil acidity can be rectified due to with the application of the lime. So that is, there are the different lime products. Those are used as the amendments for the soil acidity. One is limestone, burnt lime, and another third one is the basic slag. Here, the byproduct from the fertilizer factories, fresh mud cake from sugar factories. Also, we can use as an amendment for the rectifying the soil acidity. The amount of lime required mainly depends upon the soil type, whether it is, light soil or heavy soil, and depend upon its pH. If it is how to what extent the pH is having, whether it is having 4, 5, 6, 7 like that. So if the lower the pH, soil pH, the higher amount of the lime is required. And then if the texture is fine, suppose clay soils, it requires higher amount of lime when compared to the coarse structured soils like sandy soils in the same pH level. So the suppose same pH level, suppose for example pH is suppose 5. At the 5 level, if the soil type is heavy soil, that is clay is more, it requires more amount of lime, and if it is the light textured soil, it requires less amount of the lime. So the soil texture also plays important role for fixing the amount of lime to be added for to rectification of the soil acidity. Usually 2 to 3 tons of the lime is applied on unplowed land and then disked to the mix with the soil. This application is to be done 10 to 15 days before taking up the sowing. Another important aspect is the integrated nutrient management for the better soil health management. You know this whatever the soil organic manures, these are the very there is a constant in the availability of the organic manures, and also it contains very low amounts of nutrients. The for to meet the requirement of the nutrients by the different crops, so we need to add more volume of the organic manures, which may not be available for the farmers. So for this purpose, integrating with the organic manures with the inorganic fertilizers, it is the better practice advised. That is called the integrated nutrient management. Integrated nutrient management, it is improved and high yielding varieties of the crops require the what happened when there is we have nowadays high yielding varieties of the crops. Many high yielding crops we got now, the farmers are taking up. So these crops require application of the heavy amounts of the fertilizer and controlling the, so naturally the infestation of the pests will be more. So the controlling infesting pests to get the best benefit of the growing such varieties. So but what happens due to the application of the high fertilizers, So there is a imbalance of the use of the nutrients. So the continuous and imbalanced use of agrochemicals like pesticides and fertilizers, which affects the soil health by adversely affecting the soil microorganisms, and the leftover chemical residues become toxic to the plants. So this is the declining fertilizer response day by day, year by year. The fertilizer response is getting decreased. We see the during the 19 years during 1970, so there was a response ratio of the NPK. So there is a response ratio that is 13.4 kg was response with the 1 kg of the NPK, 1 kg of the NPK. Then you see the year by year, 1980 still it declined to 8.2, and 1990 it declined to 5.8. Now finally, during the 2010, the response ratio of the NPK is only 3.7. The response ratio is becoming very low. It is the problem. So then nutrient deficiencies, year by year, the nutrient deficiencies, number of nutrients becoming deficient is increasing. If we see the during the 1950 year, then the people were using only the organic manures. So they were not using the fertilizers, that is organic, inorganic fertilizers. At that time, very low yielding crops were there. Only my organic manure application was there. So there in the soils, there are mainly nitrogen element was deficient during those days. So day by day, when coming to 1960, the iron was has become deficient element added in addition to the nitrogen. And during the 1965, again the phosphorus element was added as a deficient during 1970, and one more element, zinc, was added as a deficient element in the soil, and phosphorus also. So then we see the 1980, then in addition to the nitrogen, iron, phosphorus, zinc, copper, the sulfur and manganese were also added. So day by day, year by year, the elements identified as a deficiency are increasing. So now during the 1985 and 90, the boron deficiency has been recorded in the soil, and during the 2010, again one more element, molybdenum, is added as a deficient element in the soil. So this is mainly because of the nutrients we are applying, only major nutrients. We are not applying these micronutrients like boron, zinc properly. So and taking up the high yielding crops day by day, the crops are taking those elements which we are not applying. Those are taking the elements from the nutrients from the soil. So the availability of those nutrients in the soil is declined, and it leads to the deficiency of those particular nutrients in the soil. Nutrient status of the NPK. For example, if you see the what is the status of the nitrogen, phosphorus, potash in the Indian soils, here this percentage deficiency, and here you see that, for example, nitrogen. This is the nitrogen, phosphorus, and potash. If you see the nitrogen, 63% of the Indian soils are deficient in nitrogen, and 26% of the soils are medium in nitrogen, and 11% of the soils are high in nitrogen. So most of the 63% is of the soils are having deficient in the nitrogen. Then when coming to the potash, when soil phosphorus, then the here, if you see the 42% of the soils are deficient in phosphorus, and 38% of the soils are medium in phosphorus, and 20% of the soils are rich in phosphorus. So the if we coming to the potash, in contrary to these elements, only 13% of the soils are having deficient in potash, and more than 50% of the soils are rich in the potash in the Indian soils. So this is the scenario about the NPK status in the different soils. So this is the nutrient status about the micro and secondary nutrients. So the sulfur was deficient to the extent of 41% in the Indian soils, and the zinc is deficient to the extent of 49% in the Indian soils, and boron was deficient to the extent of 33%, molybdenum to the extent of 13%, iron to the extent of 12%, and magnesium to the extent of 5%, and finally copper to the extent of only 3%. So here you see the boron. Boron is also coming slowly in limited nutrient. Mainly it occurs in the acid soils in the country. So this important micronutrient deficiency among all the micronutrients is the zinc. Zinc deficiency is more common in the soils of the different states in the country, and the zinc deficiency is also approved in many of the crops under Indian soil conditions. So the Maharashtra, it tops the 86% of the soils in the Maharashtra are deficient in nitrogen, followed by the Karnataka 73%, Haryana 61%, Tamil Nadu 58%, Meghalaya 57%, Orissa 54%, Bihar 54%. Coming to the unified, that is undivided Andhra Pradesh, the deficiency was up to the extent of 49%. Then we take exclusively the Telangana area, it is more than 55% of the soils are deficient in the Telangana soils. So if you see the Assam, Gujarat and Rajasthan, the deficiency of zinc is very less when compared to the other states in the country. So nowadays, after zinc, the boron deficiency is the most common element, micronutrient element observed as a deficient in the soil. So the maximum deficiency, the is 69% of the boron deficiency is recorded in the Orissa soils, followed by the soils in the West Bengal, and followed by the soils in Bihar and Karnataka, UP. Madhya Pradesh, Tamil Nadu, Assam, and finally Punjab. Here in combined Andhra Pradesh, we have noticed the boron deficiency in the Godavari districts, East and West Godavari districts of Andhra Pradesh area, where the most predominant crop is the coconut crop is being grown there. So those soils are more than 50% of the soils are deficient in boron. So the boron deficiency is also being observed in the coconut crop very predominantly, which leads to the recommendation of the boron spray on the coconut crop. So some of the districts we have made it average the soil fertility status. If you see the organic carbon content, 96% of the soils. We have, this is the analysis analytical data of the about 5,700 samples. The mean data of the 5,700 samples. 96% of the samples are deficient in organic carbon. Almost all the soils are deficient in nitrogen, and only 3% of the soils are deficient in available phosphorus, and 6% of the soils are deficient in available potassium. Why? Because the phosphorus is also less deficient. Is the farmers are using diammonium phosphate and other complex fertilizers as the top dressing. Actually, the phosphorus application is not required as the top dressing. Phosphorus nutrient is required for the establishment of the root growth at the initial stages only. Instead of using phosphorus fertilizers as a basal, farmers are in practice of using phosphorus containing fertilizers like DAP and other complex fertilizers as a top dressing also. So it is leading to the sufficient amount of the phosphorus nutrient in the soil. So the only 3% of the soils are deficient in the phosphorus. And then available sulfur, 29% of the soils are deficient in sulfur. Mostly the coarse textured soils and the areas where with high rainfall amount, those soils are deficient in sulfur. And other micronutrient deficiencies, 22% of the samples are deficient. This is the data with regarding to the limited area. So that this is now it does not reflect the total state. So this is the status in the different soils of the different districts. That is undivided Andhra Pradesh at the time. So Anandpur, the maximum, the 14%, that is 85% of the 14%. It is showing the Anandpur was the maximum deficiency, and Karimnagar, you see, the Karimnagar was 20% deficiency recorded, Krishna 20%, Mahbubnagar 28%. So the so these are the quantities deficient in the the zinc content in the soil, reflecting the data of the different districts. This is the boron status. The Anantapur district, the soils are having more deficient in the boron, followed by the Karimnagar 32%, and Karnool 32%, Mahbubnagar 35%. So integrated nutrient management for soil health and productivity. This is very important. INM practice is very important for the sustained, soil productivity and good soil health management. So INM it envisages the conjunctive use of the chemical fertilizers in combination with the organic manures and also biofertilizers, which enhances the nutrient use efficiency, soil health, crop yields, and profitability. There is a need to augment supplies of the organic manures, fortified, coated, and customized fertilizers, supplying secondary and micronutrients, biofertilizers, and soil amendments to have integrated nutrient management and sound footing. So the INM, what happens? The not only the application of organic manures with the in combination with inorganic manures and applying the fortified manures. That means, for example, the NPK fertilizers fortified with the micronutrients. That is like zinc, iron, like that, and coated neem coated urea to improve the release of the nutrient from the fertilizer. Slow release. It leads to the slow release and customized fertilizers. Wherever the nutrient is needed, there we have to use the customized fertilizers. So these are the different types of practices which we follow in the under the integrated nutrient management for improving the soil health. So the site specific nutrient management is another important aspect. So organic manures, if we take under the manures, the organic manures, it includes farmyard manure, farm compost, town compost, night soil, starch, green manures, fresh mud cake, poultry manure, vermicompost, and phosphogypsum, etc. So these we have to applied in bulk quantities because to supply more nutrients we have to apply in the bulk quantities, and supply of the plant nutrients are very small quantities when compared to the inorganic fertilizers. It supplies the organic matter in large quantities, but the main advantage due to the addition of the organic manures, it may not supply the nutrients in a big, larger quantities. It supplies very limited quantities, but the main advantage is it improves the organic matter and it will lead to the chelation in the soil and it makes the available nutrients, unavailable nutrients into the available nutrients forms. And also it improves the soil structure, soil texture. Of the various organic manures, the farmyard manure is the topmost available organic manure in the country. And next one, green manure. These are the most important and most widely used organic manures. What is the effect of the organic manure? It supplies the plant nutrients to some extent, and as I told you earlier, it improves the soil physical properties like soil texture, structure, and water holding capacity through the addition of the organic matter. It also acts as a substrate for the soil microorganisms. So soil microorganisms they will take, their energy source from the soil is organic matter. So it acts as a substrate for the soil microorganisms. So then, what is the effect of adding farmyard manure on the yield of the different crops? Suppose what happens if we will spread the farmyard manure on the field. Sometimes we will plow immediately. Sometimes we will plow after 6 hours after spreading. Sometimes we will plow next day. Sometimes we will plow after 2 days. So what will be the effect of the spreading of the farmyard manure and plowing it? What is the effect on the different increasing the yield? Suppose if we spread the farmyard manure on the field and immediately plow, so there will be the good effect on the yield, improving the good yield increase. So then when we plow the farmyard manure after incorporation, after spreading, after 6 hours, so the yield increase is only to the extent of 86%. If we spread the farmyard manure and followed by plowing after 26 hours, the increase in the yield will be only 70%. So if we take 36 hours to plow after spreading the FIM farmyard manure in the field, the increase in the yield is only 44%. So this year the recommendation which we give to the farmers is immediately after spreading the farmyard manure in the soil, on the soil, we have to plow immediately to increase the effectiveness of the farmyard manure so that we'll get the maximum advantage in the increase in the yield out of the application of the farmyard manure, immediately plowing in the field after application. The green manuring, there are different types of the green manures we will take up for in-situ incorporation. Those are non-legume crops, legume crops. So non-legume crops are the daincha, sanem, pilipesra. These three are recommended as the, green manure crops. We'll grow these green manure crops during the off-season time, and we'll incorporate these crop before the flowering. So it leads to the addition of the organic matter in the soil. Then green legumes, they, for example, like green gram, black gram, coffee, we'll take up these crops as a, crop that pods to get the pods also, and we can incorporate the green manure crops in the soil also. It will fixes the nitrogen from the atmosphere. It will be added to the soil. So the green leaf manuring, these leaf manuring, we collect the leaf samples. Leaf bulk quantities, leaves from the different crops outside the field and incorporation in the field, like shrubs, glyristeria, wild daintia, wild indigo, etc. And from we will take the leaves from the tree crops also, the like pongamia, stubble, Ambrosia, wild acacia, like that. We'll collect the leaves and incorporate into the soil. So these are the different types of the green manuring being added to the soil. So what are the advantages? These are the valuable potential source for the nitrogen and organic matter. When incorporated into the soil, it partially meets the nutrient requirement of the crops. Not fully it meets, only partial, because it contains very less amount of the nutrients. Besides being the source of the phosphorus, potash, and sulfur, this is also the source for the different micronutrients, and it also influences the availability of the nutrients through its favorable impact on oxidation reduction regimes and pH and increased chelation capacity. So, due to the indirect effect of these, the availability of the nutrients will be increased due to the addition of the green manuring. So, it plays an important role in the reclamation of the salt affected soils and improvement of the physical and biological properties. So these are the different types of the green manure crops like daincha, sunhemp, cowpea, pilipesara. So these are the recommended dose of daincha. The recommended dose is 9 to 10 tons per acre. Sunhemp 5 to 6 tons per acre. And cowpea 5 to 6 tons per acre. And pilipesara 3 to 4 tons per acre. So how much the plant nutrients NPK are being added due to the addition of 1 ton of these different types of green manure. If we add the 1 ton of green manure of Daisha, we will be adding nitrogen to the extent of 6.2 kg per ton of green manure, and phosphorus 1.5 kg for the ton of green manure, potash 4.6 kg for 1 ton of green manure. If you see the four types of green manure crops, the maximum amount of nitrogen is being added through the Sanamp, Cowpea, and Pilipestra when compared to the Daincha. Here, the little bit low addition of nitrogen through the Daincha. The mostly Sanamp, Cowpea, and Pilipestra addition will lead to more nitrogen addition. So then, what is the effect of the age of the green manure crop and time of budding on the field of the paddy crop yield? So this experiment, where the Daincha crop is used as the green manure crop. So what is the effect of the age? For example, we'll take up 8 weeks of old Daincha and incorporated, and for example, 12 weeks of old Daincha taken and buried. What will be the effect of the incorporation of the 8 week age of the world Daincha and 12 weeks of world of the Daincha? So in general, what we'll see, again it varies depend upon the, addition of this aged Daincha crop after how many days of the planting. For example, buried 8 weeks before the planting, before taking up the crop, 8 weeks before, if we add 8 weeks age of old Daincha, we are getting 3017 kg per hectare. And if we are adding 12 weeks age of old Daincha, we got 3141. There is increase in the increase in the yield of the paddy when we add the dye of the 12 weeks age dye crop, 8 weeks before the planting of the paddy. This is the maximum highest result we got. So that is the incorporation of the 12 weeks old dye 8 weeks before the planting of the paddy. So this is the highest yield we recorded. Then if we bury the 4 weeks age of the 4 weeks after planting of the paddy, then what is the 8 weeks age crop incorporation? That is 3024, and 12 weeks old age 2965 uh, kg per hectare. So what happens? The 8 weeks before planting, it is okay. 12 weeks is old age is okay. But if we take up the before 4 weeks, if we want to, take up that incorporation, the 8 weeks of old age was comparatively better than the 12 weeks old age. So the paddy crop grown without any green matter, you see the 2,800 kg per hectare. So if we compare with the crop where we have taken without the application of green manure and with the application of the green manure. So there is a drastic increase in the yield kg per hectare of the paddy due to the incorporation of the green manure. The addition of the organic matter and humus to the farmyard manure and green manure. Green manure are not as effective as farmyard manure for unit of carbon in increasing the organic matter content of the soil because of their greater decomposability. The decomposition is very fast uh, in green manures incorporation and compared to the farmyard manure. So due to the greater decomposability, so these are not as effective as farmyard manure in addition of the carbon per unit area. So the addition of 50 tons of coffee dry matter, it increased the humus content of the soil by the 2.7 tons. But whereas the same quantity of the 550 tons of the FIM dry matter is increased the humus content of the soil by the 8 tons compared to with the untreated. So you see the more humus content is added with the addition of the 50 tons of farmyard manure when compared to the addition of the 50 tons of the coffee, mainly due to the fast decomposition rate due to the addition of the copy. Then it is another important aspect is the humid acid application. So humid acid, there are the different sources of the humic acid sources. Those are the coal, lignite, and different soil organic matters are there, which are the humic acid sources. So the lot of research is going on the effect of application of humic acid at different rates ranging from 5 to 10 kg per hectare. It increases the nutrient holding capacity of the soil. So next fertilizer after green manure crops and the vermicompost is very important. Fertilizer, organic manure fertilizer. It is made up of with the earthworms. So it contains nitrogen 1.9%, phosphorus 2%, potash 0.8%. It also contains the micronutrients to some extent, that is zinc 100 ppm, copper 40 ppm, and manganese 500 ppm. So these are the, when compared to the farmyard manure, the NPK contents are a little bit more. For example, FIM, it is having 0.5% nitrogen, here 1.9% nitrogen. So comparatively, more amounts of the nitrogen and phosphorus and potash in the vermicompost. Also, it contains the micronutrients, and it also contains even amino acids also, which are used for the as a hormone for the crop growth. This vermicompost is the very, it is may not be available in much quantities for the farmers. It is being used for the high value crops like vegetable and fruit crops. Next, poultry manure is also very important. Nowadays, the lot of poultry farms are being established in the country. So the poultry, a lot of poultry manure we are getting out of poultry farms available. This will be available to the farmers. So it contains more amount of the NPK. Even it is more than or will on par with the vermicompost. This nitrogen 1.8%, phosphorus 2.5%, potash 1.4%. These are but here when we see the phosphorus, here phosphorus is 2.5% in the poultry manure, whereas in compost it is 2%. So the phosphorus content is more in poultry manure when compared to the other organic manure fertilizers, other organic manures. So the release of plant nutrients is very fast. 49% of the total nitrogen in poultry manure will be mineralized in just in 4 weeks as compared to only 12% in the FIM. So among the manures, organic manures, the availability of the nutrients is more and fast due to the addition of poultry manure when compared to the farmyard manure. So these are the oil cakes rich in nutrients, groundnut cake, castor cake, mawa cake, orange cake. They will be having high amounts of the nitrogen and phosphorus and potash. These will be used for the high value crops. So another one, biofertilizer, it is called biofertilizer, but actually it is not a fertilizer. It is a term, biofertilizer is a misnomer. Biofertilizers as such, they do not supply the plant nutrients. The biofertilizers, they enhance the soil fertility and crop productivity by fixing the atmospheric nitrogen and mobilizing the sparingly soluble phosphorus in the soil, and by facilitating the release of the nutrients through the decomposition of the crop residues. So the biosphere fertilizers, the main usefulness of the biofertilizers is it fixes the atmospheric nitrogen, and whatever the unavailable phosphorus in the soil is there, it will make it available form, and it facilitates the unavailable form of nutrients into the available forms through the decomposition of the crop residues. These are the different types of fertilizers. Nitrogen fixers are there, symbiotic and non-symbiotic. Symbiotic means these organisms, they will live in association with the plants, different types of plants. Here they will mutually benefited. The organisms, they will take energy as a source from the plants, and plants in turn they will take the nitrogen from the nitrogen fixers. So this is the mutual, benefit of the both soils and microorganisms. Here, non-symbiotic, they don't depend on the source. Azospirillum, for example, cereal crops, Azotobacter, it is only used in the sugarcane crop, and there are some non-associative fixers are there. Micro biofertilizers, they are Azotobacter, they are used in vegetables and flowers, and blue-green algae, this is mainly used in the rice crop, flat rice crop. Then phosphate mobilizers or solubilizers are there. Important is the VAM, that is vesicular arbuscular mycorrhiza. Mycorrhiza. This is more useful in orchards, and the bacteria Bacillus Megatherium, Bacillus polymixa, Bacillus subtilis, Bacillus Pseudomonas strata, Bacillus rhathoris. These are the different types of the, I mean, this mycorrhiza bacteria. These are the different types of the bacteria, sorry. The Bacillus megatherium, Polyxemia, these are different types of the bacteria. And other fungi also available, Aspergillus niger and Penicillium digitatum are the different types of fungi. Fungi is more effective when compared to the bacteria. So biodecomposition accelerators also there, just like cellulolytic and lignolytic. So then, for the soil health management, one other important aspect is site-specific nutrient management. So in whatever we are nutrients application is there, that is based on the blanket recommendation, and we are applying as per the recommendation of the different crops. But whereas in site-specific nutrient management, it is a set of nutrient management principles combined with good crop management practices that will help the farmers to attain the high yield and to achieve the high profitability both in the short and medium term. It is an approach for the timely application of the fertilizers at optimal rates to fill the deficiency between the nutrient needs of the yielding crops and the nutrient supply from naturally occurring indigenous sources, including soil, crop, residues, manures, and irrigation water. So here what happens, it will take the what is the actual situation in that particular area, if that particular soil is which is deficient in which nutrients, and which fertilizers we are applying, what is the gap for the need of the nutrients. So we'll take up that nutrient application only. It is a site specific. On site-specific nutrient management, it mainly aims to optimize the supply of the soil nutrients over the time, and it spares to match the requirement of the crops through four key principles called 4 Rs. So this is the R's means what is that? Applying the right source of the source. That is one right source. Another is that right dose. Third one is the right time. And fourth one is the, at the right place. Whether it is the broadcasting, whether it the basal, at the and base level of the plant, or in the at the root zone. So different places. And right time, whether it is basal or whether it is top dressing, and after how many days after sowing of the crop, like that, it is the right time we have to select. Right dose, what actually the crop needs. It varies depend upon the nutrient available in the soil. Right dose we have to fix. And right source, which source? For example, we need only phosphorus. What type of fertilizer we have to use? We should not use the other than phosphorus content fertilizers. Where it is needed, that particular source we have to select. So those are four R's: that right nutrient source, right dose, right time, and right place. More, these are the four important R's to the nutrient stewardship in the specific nutrient management. Such four R nutrient stewardship for fertilizer-based management practices is an approach that considers the economic, social, and environmental dimension of the nutrient management. So, under site-specific nutrient management, one important aspect, that is precision agriculture. Precision agriculture offers the opportunity for a sustainable, that is economically sound and an environmentally acceptable way of the farming. The objective of the precision farming is, among others, to increase the efficiency of the fertilizer inputs by identifying the spatial variability of the soil parameters. So the applying the right nutrient source at the right rate, at right time, at right place is essential for nutrient stewardship. For fertilizer-based management practices is an approach that considers economic, social, and environmental dimensions of the nutrient management. And the site-specific farming is the managing the areas within the fields rather than using the same management to the entire field. For example, it is some particular plant, the soil nutrient condition, soil characteristics may vary from place to place within the plant. So depending upon the variability, spatial, we're taking into consideration the spatial variability, we have to select the sources of the fertilizer, we have to select the right dose of the fertilizers and application, so that we can reduce the cost of inputs, that is cost on fertilizers, and we can increase the profitability. It aims at the nutrient supply at optimal rates, as I told you, and it times to achieve the high yield and efficiency of the nutrient use the crop. Soil nutrient supply potential and its spatial variability, productivity potential, and targets for the crops and cropping systems, estimation of nutrient requirements, and fertilizer use efficiency, besides assessment of the resource quality and socio-economic background of the farmers, are the very much essential for developing the site-specific nutrient management practices. Any deficient application of the fertilizers will limit the crop yields, facilitate the nutrient mining, and result in the depletion of the soil fertility. For example, the zinc fertilizer is deficient. So, for example, zinc is the deficient in the soil. It limits the, because of the limitation, it limits the yield. So that what you have to done, without application of the zinc, it is mining much and much zinc from the soil, more and more deficiency to be coming. So application of that zinc fertilizer, it is more important. That is the site-specific management we call to maintain the soil fertility properly. The excessive or imbalanced application not only wastes the limited sources but also has the potential to pollute the environmental. For example, in the farmers generally they are using high amounts of the nitrogen fertilizers beyond the recommended dose of the application for the different crops. They are going beyond the recommendation doses. So it leads to the, more amount of nitrogen added to the soil, that is it becoming nitrate pollution, and it is polluting the environment also. And the excess amount of use of one nutrient, it will leads to the deficient of the other nutrients. So there is the imbalanced application of the nutrients. So an approach towards the mitigating such concern is the site-specific nutrient management, which takes into account the spatial variation in the landscape. So the site-specific nutrient management, it will take care of the balanced application of the nutrients and application of the nutrients wherever it is needed in that specific area in the plant. So we use the GPS and GI systems in the site-specific nutrient management. Widespread adoption of the site-specific nutrient management technologies based on the soil testing requires extensive soil sampling and analysis could be the intense considering the available infrastructure. Use of global position system, that is GPS, and use of GIS, that is geographical information system, and mapping can provide the right support as cost-effective alternate. So these are the two steps under the site-specific nutrient management, establishing the attainable yield targets. We have to fix what amount of yield we want to get. So depending upon that, we must take what are the availability of the nutrients in the soils, what is the gap of the fertilizers we need to apply. So these are the things taken care under soils site-specific nutrient management. It effectively use the existing nutrient sources, application of fertilizers to fill the deficient between the demand and supply of the nutrients. Just now I told you. The concept of site-specific nutrient management, it is one nutrient management and recommendation process in India is still based on the response data arranged over the large domains. The site-specific nutrient management provides an approach for need-based feeding of the crops with nutrients while recognizing the inherent spatial variability. So what we are following earlier is the just a response based on the response studies recommended dose of fertilizers we are adding in blanket to the total plant. But if we take into consideration spatial variability, the variability within the plant, within the specific area, and what is the need of the crop in that particular area will be taken into consideration under site-specific nutrient management. So it involves monitoring of all pathways of the plant nutrient flows, supply, and calls for the judicious combination of the fertilizers, biofertilizers, organic manures, crop residues, and nutrient-efficient genotypes to sustain agricultural productivity. It also avoids indiscriminate use of fertilizers and enables the farmers to dynamically adjust the fertilizer used to fill the deficient optimally between nutrient needs of the variety and nutrient supply from the natural resources, organic sources, irrigation water, etc. The different parameters essential for the practicing the site-specific nutrient management, soil testing nutrient supply potential, and productivity target of the crops and cropping systems and nutrient needs. Each ton of grain removes about 82 kg of the nutrients, which do vary with the crops and productivity depending upon the fixing of the target of that particular crop. What is the amount of nutrients needed for the proper growth of the plant and what are the availability of the nutrient in that particular soils in that particular spot and what is the amount of nutrient we should add. These are the main things we have to take under consideration and site specific nutrient management. The efficiency of nutrient sources, that is fertilizers, organic nutrient sources like farmyard manure, green manures, compost, biofertilizers, organic and industrial waste and soil amendments. There are different nutrient efficient genotypes also there. We have to take into consideration for better soil health management and under the site specific nutrient management. The selection of the suitable crops and cropping systems is very important. The cropping systems and crops they should involve nitrogen fixing crops so that for the better management of the soil health. Then correction of the soil and nutrient related problems. For example, acidity, alkalinity, saline alkalinity, all these problems should be corrected under the site specific nutrient management for the better health soil health management. There are the different features criteria for the soil site-specific nutrient management. Optimal use of existing indigenous nutrient sources such as crop residues and manures. Whatever the residues available for the farmers, whatever the sources of the organic manures available for the farmers locally. So they should use those indigenous nutrient sources should be included under the soil site-specific nutrient management for that particular area. The application of the nitrogen, phosphorus, and potash fertilizers is adjusted to the location specific and season specific needs of the crop. Already I told you, depend upon the location, depend upon the variability in the soil, we have to take up the NPK fertilizer application adjustment. Use of leaf color chart ensures the nitrogen is applied at the right time and the actual amount of needed by the crop, which prevents the wastage of the fertilizer. So we are using a blanket dose of the fertilizer. Whenever it is not needed, also we are applying to investing a lot of amount is wasted in investing on the inputs so that we are reducing the profitability. So to decrease the wastage of money and the wastage of the not required use of fertilizers. We can use the leaf color chart. It is a very good method, using the leaf color, comparing with the chlorophyll content in the leaves of the different crops in the soil, recommending the different doses and what is the time it is needed. Use of nitrogen omission plots to determine the phosphorus and potash fertilizers also required to meet the crop needs. This ensures that phosphorus and potash are applied in the ratio required by the rice crop. The different futures criteria, that is the land randomization for application of the zinc, sulfur, and micronutrients are followed. So depend upon the variability, we have to divide into the plat, and so local randomization will be there, and depend upon that we have to apply zinc, sulfur, and micronutrients which are needed. And selection of the most economic combination of the available fertilizer sources, which is the best combination of the NPK we should apply for that spot, for that area in within the plant. So that is most important under site-specific nutrient management. Integration with other integrated crop, not only this integrated nutrient management, with it is integrating the other crop management practices such as the use of the quality seeds and maintaining the optimum plant density. There should not be any gaps, and integrated pest management and good water management. These are to be associated with the integrated nutrient management under the site-specific nutrient management. The site-specific nutrient management recommendations could be evolved on the basis of the solely plant analysis or soil cum plant analysis. Plant analysis based soil-specific, site-specific nutrient management. Here, the nutrient status of the crop is the best indicator of the soil nutrient supplies as well as the nutrient demand of the crops. This approach is built around the plant analysis. If plant is having more element, that means it is taking the element. The soil is also having more amount of the element. The selection of the yield goal. What is the target will fix? How many tons of the target will fix? Depend upon that, it varies. So yield goal of exceeding 70 to 8% of the variety specific potential yield has to be chosen generally. The assessment of crop nutrient requirement and important estimation of the indigenous nutrient supplies. Indigenous nutrient supply is defined as the total amount of the particular nutrient that is available to the crop from the soil during the cropping cycle when other nutrients are not limited. And you should compute the fertilizer nutrient rates. Field specific fertilizer, nitrogen, phosphorus, and potash recommendations are to be calculated on the basis of the, on the basis of these different steps and the expected fertilizer recovery efficiency, that is the kg of the uptake for the kg of the applied fertilizer, and dynamic adjustment of the nitrogen rates, how to adjust. So they depend upon the need by the crops, depend upon the availability in that particular area, we have to adjust the nitrogen rates. Soil cum plant analyzer basis site-specific nutrient management. Here, in order to ascertain desired crop growth not limited by the apparent or hidden hunger of the nutrient, soil is analyzed for all micronutrients well before sowing of the plants. Specific fertilizer rates are then suggested to meet the nutrient demand of the crop without depleting the soil reserves. So the soil testing crop response based recommendations are now in practice to achieve the desired yield targets in many field crops. What are the benefits from the site-specific nutrient management? Uniform crop stand with more yields and increase in fertilizer and other input efficiency. More saving of the inputs, it leads to the more amount of profit. It ensures the balanced application of the fertilizer, protect the environment, so there will not be much environmental pollution, and there will be, when we use the balanced dose of the nutrients, there will be the less amount of the pest disease incidents, so that we can decrease the cost of pesticide application and increasing the profitability. So identification of the yield potential variability within the yield and site-specific nutrient management reduces the nitrous oxide emissions into the atmosphere by reducing the nitrogen application and timing of application to crop needs, thus avoiding the nitrogen losses to the volatilization, leaching, and runoff. This more the two aspect advantage, the nitrous oxide emission in the atmosphere. So they controlling the pollution in the atmosphere, and another one is the pollution of the nitrates in the groundwater. So when the heavy nitrogen application, it leaches to the underground water, and underground water is contaminated with the nitrates. So when we apply underground water to the soil, again nitrate pollution is the main aspect. So these two pollutions will taken care of with the site-specific nutrient management. So it improved the disease resistance also. So, but there are, even though we have a lot of advantages with the site-specific nutrient management, there are some limitations in adaptation. So the technology and knowledge requirements may not be fully available to the farmers. It requires knowledge of underlying soil properties and the ability to monitor the crop nutrient status and adjusting the fertilizer inputs accordingly. So the technical advice is needed for the site-specific nutrient management. There is a need to conduct the on-farm nutrient trials and soil tests has to be a barrier for the implementation of the site-specific nutrient management. The availability of the fertilizers also is one of the concerns. Sometimes we need some specific fertilizers that may not be available in the market nearer to the farmers. So that is another constant. The cost and access to the fertilizers, whether synthetic or organic, it is not universal, and the development of input markets or identification of the farm nutrient sources may be the necessary precursor. There is the variable economic benefit for site-specific nutrient management. To increase the benefits for farmers, it must deliver either savings from the reduced fertilizers use without reduction in yields, or yield increases that are valued higher than the cost of acquiring and using site-specific nutrient management technology. So the when the site-specific nutrient management technology is followed by the farmer, when it will be effective is only when it delivers and it is advantageous in cutting down of this expenditure on the inputs, so that increasing the savings from the reduced application of the fertilizers, and without reduction in the any yields also it is good, or even increase in the yields it is still better. When then only the site specific nutrient management will be is called effective. So the problems in adapting site-specific nutrient management in India, the main in Indian conditions, there are the small farmers. Volume is more. So there are small land holdings are there. Due to the small land holdings, where small and marginal farmers follow subsistence farming, do not allow successful use of high technical tools such as GPS and GIS. The high cost of equipment and lack of availability is also a major problem. It may not be available at the farmers level. So, though the leaf color chart is the cheaper transfer of technologies, again it is a problem. uh, then you see, so the leaf color chart, it is a cheaper source. Even though transfer of technology is a problem, but it is a cheaper source to identifying the nitrogen need of the crops when to apply the nitrogen. This is the leaf color chart for nitrogen fertilizer recommendation for the different crops. The constant in use of nitrogen fertilizers, is the difficulty in determination of the nitrogen doses. What is the dose nitrogen required? Very difficult. In traditional methods, nitrogen usage efficiency was only it is less than 22 to 30%. Less availability of the nitrogen fertilizers was also constant. The cost of the nitrogen fertilizers are more high cost. Use of less nitrogen fertilizers, plant growth is affected and yield reduction. If usage is more, there will be the crop lodging and pesticide incidents will be more. It leads to the pesticides application more. And environmental groundwater pollution, if more nitrogen is used, just I already told the nitrate pollution in the underground water and nitrous oxide pollution in the atmosphere. So the loss of nitrogen due to the volatilization, denitrification, leaching, and runoff losses if more nitrogen is used, harmful effects on other nutrients also. Imbalance with a high amount of nitrogen, it leads to the deficiency of other nutrients. So these are the constants in use of the nitrogen fertilizers. The blanket recommendation of for applying fertilizer nitrogen to crops cannot help increase the fertilizer use efficiency beyond a limit. This is a leaf color chart. It is a cheap source of the, source available for the farmers for application of the nitrogen. They can use very easily. Leaf color chart help in determination of exact dose of the nitrogen requirement and hence reducing the nitrogen losses. A leaf color chart is also cheapest and easiest tool of nitrogen assessment and management. Leaf color chart is an instant, easy, and low cost technique for nitrogen diagnosis of the current crop and nitrogen top dressing in crops. A leaf color chart is an integrated tool with help rice, maize, and wheat farmers to visibly assess the need for nitrogen, to apply the fertilizers at the right place, right time, and right amount when crop needs it. It generally leaf color chart leads to the saving of the nitrogen because of the farmers are having tendency to use the more nitrogen fertilizers. There is an average saving of the 20 to 50 kg nitrogen per hectare by using the leaf color chart. Mainly, the advantage of leaf color chart is we can save the amount of nitrogen applied 20 to 50 kg, so that we can save the money on the nitrogen fertilizer unnecessarily uses, and we can apply the nitrogen whenever actually crop it needs. So that will be identified by the through use of leaf color chart. So there are the different leaf color charts certified by the different organizations. This is the one International Rice Research Institute during 2002, and Central Rice Research Institute at Cuttack, and another one is Directorate of Rice Research. Now it is called Indian Institute of Rice Research, ICR Institute at Hyderabad, and Punjab Agriculture University, Ludhiana, and Tamil Nadu Agriculture University, Coimbatore in Tamil Nadu, and Kerala Agriculture University. These have also certified the different leaf color charts. These organizations they have certified. So leaf color chart for assessing the nitrogen requirement of the crops. The leaf color chart had been jointly developed by International Rice Research Institute, Philippines, and Rice Research Institute, Philippines, this in Cuttack, India. So jointly developed. Then it is based on the leaf color. Mainly, it is the leaf color. How the depend upon the chlorophyll content, it looks like dark green, moderate green, and less green. So based on the leaf color, we'll compare with the leaf color chart with the actual leaf color in the field. So easy tools for the need and assessment of the nitrogen in paddy, maize, sugarcane, potato, and vegetable crops. How to use the leaf color chart? The first of all, we have to select the 10 healthy plants at random from 14 days after transplanting. If it is a transplanted crop, we have to select the healthy plants at the 14 days. If it is the sowing crop, seed sowing crop not transplanted, 21 days after the sowing of the plant. We have to select the 10 healthy plants. So now compare with the leaf color chart of these 10 healthy plants, that is fully extended leaf only, and we have to compare the leaf color during the 8 to 10 a.m. in the morning hours and 2 to 4 p.m. in the afternoon hours. And one important thing is that in the time of measuring, do not penetrate the light in the plant, so make it as a shade. There should not be shade reflecting the wrong diagnosis of the leaf green leaf color comparison. Only 1% take the reading from first to last, because there is a visible areas from it varies from person to persons. So one person should take the samples, compare the samples, leaf samples color with the leaf color chart throughout the, I mean, all the samples in the field. So take a reading for every 7 to 10 days interval, so that when we can assess when it the nitrogen is actually needed to apply. So there are the different leaf color chart panels developed by the different organizations for the different crops. There is a one, company that is institution that is nitro parameters. Different panels have been developed by these nitro parameters, keeping in view the spectrum properties of the varieties popular in India. Moreover, it is more suitable to accommodate the varietal differences, if any. Depend upon the major crops like paddy, maize, vegetable crops, and some crops, they have developed different leaf color charts. For rice, there are two leaf color chart panels, that is 4 panel and 6 panel, have been developed for International Rice Research Institute. It is generalized one which can be used throughout the worldwide. So another one in collaboration with the Central Rice Research Institute, Cuttack, a new 5 panel customized leaf color chart is developed for the eastern states of India. And another leaf color chart, that is the 5 panel customized leaf color chart, was developed by the Directorate of Rice Research, that is now it is Indian Institute of Rice Research, Rajendra Nagar, ICR Institute. This is especially suitable for the irrigated ecosystem. And for maize and wheat crops, in collaboration with the Punjab Agriculture University, six-panel leaf color chart has been developed for the wheat and maize, and need-based nitrogen measurement in rice, wheat, maize using leaf color chart is the most reliable and affordable method available in developing the countries like India. So these are the different leaf color charts comparing the leaf color. So this is one panel, five panel leaf color chart. So we have to use compare the leaf color chart in the field, leaf color in the field using the leaf color chart. So this is the six-panel leaf color chart. It is very easy. It is developed by the International Rice Research Institute. It is very easy to use and inexpensive diagnostic tool for monitoring the relative greenness of the rice leaf. It is better indicator for the plant nutrient application. Then what is the procedure? Just earlier I told you to select the 10 good healthy plants, disease-free plants at random from the field, and select the topmost fully expanded leaf. Not underdeveloping leaves, we have to select all expanded leaf, we have to select and compare the leaf color of these leaves with the color of the leaf color chart panel. Measure the leaf color under the shade, so under which category it comes. They determine then 10 plants average we have to take. So the average color reading obtained from the 10 leaves has to be taken for the basis for taking of the nitrogen, fixing the nitrogen dose. Do not detach or destroy the leaf from the plant. We should not remove the leaf from the plant and compare. On the standing crop itself, we should compare the leaf color. So this is the use of the leaf chart, increasing the nitrogen use efficiency. For example, here leaf color chart, it is one is no basal application. Another is this is the 120 kg of nitrogen per hectare. The leaf color chart, when we use four panel leaf color chart, the increase in the agronomic efficiency of the nitrogen is 27.4. The 7 kg per grain it is increased. And if you use the leaf color chart 4 panel at the 20 kg nitrogen per hectare as basal, and afterwards if you use the leaf color chart, still more 28.1% agronomic efficiency of the nitrogen, and recovery efficiency is also more when we use the when we will apply the nitrogen fertilizers based on the leaf color chart. 42.7% recovery is there when compared to the recommended blanket recommended dose of the 120 kg nitrogen per hectare. So there is 30.9% recovery with the recommended dose of 120 kg nitrogen per hectare, whereas if you use apply nitrogen fertilizers based on the leaf color chart, leaf color comparison, so it varies the recovery is more, that is 42.1 to 42.7%. So these are the average of the different sites during the different years. So all the years at all the locations, the application of nitrogen fertilizers using the leaf color chart, it has increased the agronomic efficiency and also the recovery efficiency percentage of the nitrogen to the larger extent. The effect of nitrogen on the rice using the leaf color chart, these are the grain yield, straw yield, and this is the net income and benefit cost ratio. This is the control treatment. There is no nitrogen use. Naturally, there is less grain yield, and then we use apply the nitrogen fertilizer based on the leaf color chart value 3, leaf color chart value 4, leaf color chart value 5. So there are the different doses this thing fixed and applied, and there is increase in the grain yield. For example, using the leaf color chart of value 4, the maximum grain yield was observed in rice, that is 5,769 kg per hectare, and more amount of straw yield. And net income is also more, 16,150 rupees per hectare income, and the cost benefit ratio is the 1.81. Whereas the cost benefit ratio is the less in the control plant and in the recommended dose also. If we, of course, you leave the control plant where we are not using any nitrogen fertilizer, but we have to compare with the plant where we are using the recommended nitrogen dose. Here you see the recommended dose of nitrogen, the grain yield is 2917 kg per hectare, whereas the grain yield with the use of leaf color chart nitrogen application, it is around 3,800 to 4,200 kg per hectare. So the cost benefit ratio is also more due to the nitrogen application based on the leaf color chart when compared to the nitrogen application based on the recommended dose. So the leaf color chart, this is the application of the rice. So this is one experiment where we have taken biometric observations and harvest index to this experiment. Research I mean, experiment was carried by Balaji and Jawar, different two scientists. What they concluded, they compared with the NPK, the grain yield due to the application of the recommended dose of NPK and the nitrogen application based on the leaf color chart. Here we can see the maximum 1,000 grain weight was more. Of course, 1,000 grain weight was more in the recommended dose of NPK fertilizer, maybe, but filled in grains, we see the filled in grains was more, also more in nitrogen. Of course, this experiment is some erratic results they have got, but the harvest index is more in the plots where the nitrogen is applied based on the leaf color chart. So what are the points to be considered while taking the leaf color chart, using the leaf color chart? Some precautions we have to take. Nitrogen fertilizer is applied when the reading is less than critical value only. If it is less than that color, I mean, if it is telling that color with the leaf color chart where it is nitrogen application is needed, should not apply it. So it is based on the, it should be applied based on the critical less than, whenever it is less than critical value, then only we apply the nitrogen fertilizer. So the samples also, we are comparing the leaf color chart, only 1%, 1% take the reading from starting to the end. So measuring time is also that 8 to 10 a.m. morning, 2 to 4 a.m. in afternoon is effective. And the measuring of the time also, measuring make shade on LCC on leaf and leave the border 15 meters at one in wide 1 hectare area. Do not pick the leaf. So on the standing crop itself, we have to compare the leaf color. Do not select the disease and pest affected leaves. We have to select the healthy plants and fully developed plants. So advantages, it increases the crop production per hectare and it saves the 20 to 30 kg of the nitrogen per hectare. So indirectly it is saving the expenditure on the nitrogen fertilizer, improve the nitrogen use efficiency of the plants. Whenever it is nitrogen is needed, at that time only we are applying the nitrogen. Whenever it is not needed, we are not using nitrogen. So it is increasing the nitrogen use efficiency and it is very easy to use. Do not require any type of the power. It is cheap than the SPAD, comparatively less effective of disease and pests. So these are the limitations. It is less famous. The availability of the leaf color charts is the constant, and solar radiation is one constant. Critical value is different for the different varieties of the crops. Visibility of the individuals, it varies from person to person. Biological factors and other nutrient deficiency symptoms. It is only this leaf color chart is applicable for only for the nitrogen. So what about other nutrient deficiencies? So that is one constant. Economic analysis of using the leaf color chart. These are the what are the what is the cost, yield, and net income due to the traditional method, and what is the income using the leaf color chart. Here you see the cost of expenditure. Here we are using traditional method. 36,872 here 36,008 same amount of the cost of the expenditure, general cost, that is without then you see the nitrogen here, traditional method 140 kg nitrogen per hectare we are using, that it costs about roughly 1625 rupees per hectare, whereas here based on the leaf color chart only 120 kg of nitrogen per hectare is used, so that saving of the 20 kg nitrogen fertilizer. The amount has come down on the fertilizer nitrogen cost. So naturally, the application cost, then total cost is reduced. Finally, if you see the total income in traditional method, we got 76,600 rupees per hectare. I mean net income. But whereas by use of the leaf color chart, the benefit the farmer gets is 91,800 rupees. So there is a lot of increase in the total income. So net income is only 36,300 in case of traditional method, whereas in case of the method which we follow based on the leaf color chart, the net income is 50,000 rupees, 71 rupees per hectare was obtained. So there is the 14,438 rupees of the additional benefit per hectare when we use the nitrogen recommendation, nitrogen application based on the leaf color chart. So another instrument that we use is the soil plant analysis development meter. That is, it is we called as the SPAD, soil plant analysis development meter. It is a very simple, quick, and non-destructive in situ tool for measuring the relative content of chlorophyll in leaf that is directly proportional to the leaf nitrogen content. When the more reading, more chlorophyll, like that. It is directly proportional. So the SPAD readings are taken 9 to 15 days intervals, ranging from 14 days after transplanting for transplanted rice and 21 days after sowing for the wet directed seeded rice. Periodic readings continue up to the first 10% of the flowering. The youngest fully expanded leaf of the plant is to be used for the SPAD measurement. Readings are taken on one side of the midrib of the leaf blade. A mean of 10 to 15 readings for the field or plat is taken as measured at the SPAD value. Whenever SPAD values fall below the critical values, then the nitrogen fertilizer should be applied immediately to avoid this yield loss. So there are the factors affecting the splattering, nitrogen fertilizer efficiency, rice cultivar, position of the leaf on the plant, deficiencies of other nutrients like phosphorus, zinc, manganese, and iron. Then when you use this pad, what is the nitrogen effect of nitrogen on rice yield? Here you see the total applied nitrogen, that is control 120 kg nitrogen per hectare, 180 kg per nitrogen hectare. These are the when you use the 120 kg nitrogen hectare, we got 9.1 kg tons per hectare of the rice yield. Total nitrogen uptake was 132, and agronomic efficiency was 32, and recovery of the nitrogen was 61%. But whereas we apply nitrogen using the SPAD 35 and spot 37. Here is the depend upon the SPAD 35 using instrument. Then only it was needed to apply 115 kg of nitrogen per hectare. There is a lot of saving of the nitrogen expenditure. So the grain yield also increased up to the extent of 9.7 tons per hectare, and the total nitrogen uptake was 142. Then efficiency recovery percentage also increased. There's one experiment, site-specific nutrient management in rice field cropping system conducted at different places across the country. Bihar, Himachal Pradesh, Jammu Kashmir, Jharkhand, Ludhiana, and Uttar Pradesh, different areas. So there the grain yield with site-specific nutrient management for plant in bracket of the 60 average of the 60 locations. This is the average of the 42 locations, like that. 13,849 kg per hectare per year was grain yield was obtained with the specific nutrient management, whereas the farmers practice the yield was 8,658 kgs per hectare per year. So there is a lot of increase in the grain yield for hectare for year due to the application of the application of due to the implementation of the site specific nutrient management. So there are the vary in the nutrients supplied under specific nutrient management. For example, there are the nutrients required, additional nutrient required to apply based on the site specific nutrient management. For example, in an area Bihar, the four elements nitrogen, phosphorus, potash, sulfur are needed, and Palamur additionally boron and zinc were needed. So it varies from area to area. So these are the different areas in Uttar Pradesh also. Similar results with grain yield with site-specific nutrient management. There is a lot of increase in the grain yield per hectare per year. The under rain-fed conditions. This is earlier was under irrigated conditions, under rain-fed conditions for other than rice crop. That is different maize at Sripuram and maize plus Vision P at Malleponpalli and mung bean and Vision P at Nemikol. Different areas, different cropping combinations. Pigeon pit, Nandavaram, like that. So the normal fertilization, for example, maize, you take 2,980 kg per hectare of maize with normal fertilization. But whereas the normal fertilization plus boron, zinc, and sulfur, because when we follow the site-specific nutrient management, there it is needed the application of the boron and zinc and sulfur. So then, based on the site-specific nutrient management, they applied boron, zinc, and sulfur there. So there is an increase in the yield up to the 4,570 kg per hectare. So there is around 1,500 kg increase in the hectare. So the 53% increase in the yield was observed due to the implementation of the site-specific nutrient management. So like that, maize plus Fusion B system, some 75 to 80% increase. And for castor plus Fusion P also 49%, Fusion P 62% increase, castor 50% increase, groundnut plus Fusion P there is a 154%, almost double and increase in the yield due to the implementation of the site-specific nutrient management. Then the strengthening of the soil testing services is more essentially required in the country. Whatever the service of the soil testing facility presently is available in the country is inadequate with the capacity to analyze only only 7 million of the soil samples per annum against the 120 billion of the farm holdings in the country. So there is a lot of soil testing laboratories are required to be established. The need and the laboratories to participate in the preparation of geo-referenced soil fertility maps at district at black levels are needed. So National Commission on Farmers it has recommended the additional requirement of 1,000 advanced soil testing laboratories in the country. So this is the projected demand of the NPK fertilizers in the future. So in 2003 and 2010 and projected projection for the 2025 year. This is on nutrients and food grain production. Uh, for example, you see 2025. This is the food production will be roughly they will be 370 or 360 metric tons. 360 metric tons demand of the food grain will be there during 2025, depend upon the increase in the population. And then where the NPK demand, if you see, the NPK demand, it was more, that is about 45 metric tons of the NPK demand for the 2025 projection. Now it is only about 30 tons. So there is increase in the 15 tons, metric tons should be the projection is there for 2025. And the whatever the phosphorus consumption is at present roughly it is about 18 or 19 metric tons. It may increase up to 28 tons metric tons in the 2025, and likely the NPK gap. So the gap is increasing. There will be more gap of the, I mean, between the demand and the consumption of the particular NPK. So the gap is increasing during the 2025. So finally, what we conclude, there are the widespread nutrient deficiencies will be observed or being observed and deteriorating which deteriorating the soil health or the main cause of concern of the low nutrient use efficiency, productivity and profitability. So adoption of the site-specific balanced and integrated nutrient management involving the major secondary micronutrients and organic manures, biofertilizers and amendments. It should be there. So that is site-specific balanced INM practices using all other secondary micronutrients and organic manures, biofertilizers. All these combination is the best. So developing the new efficient fertilizer products which approaches the through the state of art and R&D applications and effective soil testing surveys to back up the precise fertilizer use, creating the awareness among the farmers on benefits of the balanced use of fertilizers. Uh, then Soil health is just like what we conclude at the end. Soil health is the very important and evolving concept for maintaining the soil health. All these different aspects of the technology, site-specific nutrient management, integrated nutrient management, inclusion of the micronutrients, biofertilizers, all these things to be taken care for the better soil health management. It looks at the soil holistically. Interaction of the physical, chemical, and biological factors is the most important. It is a challenge to integrate the farming practices we use with these new concepts to get the most benefit for the people and the environment. In order to achieve the targeted food production to feed the nation, it is our bounden duty to maintain the soil health as its pink of health by adopting the best management practices. So finally, the healthy soil provides healthy food, and finally, the healthy nation. So we have borrowed this health, and it is our duty to return it to the in good condition without any damage for the future generation. Thank you for hearing patiently this topic. Thank you.